So hello everyone, welcome back to my YouTube channel Z2H classes. In this video we again solve some MCQs of BARC. So here first MCQ is, which quantity remains invariant under Lorentz transformation? So we have to find which quantity remains invariant under Lorentz transformation. Invariant means do not change. Okay, so here we can see options are charge, D option is square minus b square, C option is both, and D option is none. So charge and a square minus b square both remain invariant under Lorentz transformation, so the correct option will be C. Now next question, this is very important question from quantum mechanics. This question is from commutation relation. So again, this type of commutation relations several times asks in BARC examination or CSIR NET examination or GATE examination for physics discipline. So now you should remember few commutation relations. First is commutation relation of Lx Ly gives I h cut Lz. Second is commutation relation of Ly Lz gives I h cut Lx. And third is Lz Lx commutation relation gives I h cut Ly. Here I made mistake. Here is Z, Lz Lx. Okay. So please remember this formula. Again, if you change the sequence, then there will be minus sign. That means if I write Ly Lx, then it will be minus I h cut. Okay, so if I change the sequence, then here minus sign will become. So here minus I h cut and Lz. So you can write like the, remember like this. If here x, y, then it will be z, y, z, x, z, x, y. So it is cyclic. Okay, and here you can see you are given Lx, Ly, Lz. So it is cyclic, x, y, z. So is must equal to be 0. Okay, so correct option will be 0. Again remember, Lx and Lx commutation relation gives 0. Ly and Ly commutation relation gives 0. Lz and Lz commutation relation gives 0. So now we see how it becomes 0. Okay, so let us discuss that. Okay, so let me see Lx in commutation again Ly Lz. This we are given. So first of all put the relation here Ly Lz. So what it be? It will be Lx as it is, and commutation relation of Ly and Lz will give you I h cut Lx. Since here y and z are coming, so here it will be x. Now I h cut can be taken out from commutation relation, so it will be I h cut outside the commutation relation and Lx comma Lx. As I mentioned, Lx comma Lx commutation relation will be 0. So your answer will be 0. Okay, so correct option is 0. I already now I proved also. Now move to the third question. Third question is from statistical mechanics, in which we are asked value of Fermi distribution function f of E at E is equals to EF. Here EF is Fermi energy. So you have to remember this formula of Fermi distribution function. Fermi distribution function f of E is defined as f of E is equals to 1 divided by exponential E minus EF upon KT plus 1. In Fermi distribution, or you can say in FD statistic, plus sign will come here. This sign you can see plus. In Fermi Dirac statistic it will be 1, and in BE statistic, that is Bose-Einstein statistics, it will be minus. Okay, so you are given E is equals to EF. So simple, substitute E is equals to EF here. So you will get 1 upon E raised to, here E minus EF both are same, so it will be 0 plus 1. Anything raised to 0 will be 1. So 1 upon E raised to 0 means 1 plus 1. So it will be 1 by 2, and 1 by 2 is nothing but 0.5. So the correct option will be 0.5. So correct answer is 0.5. Now next question, that is question number 4. This type of question I already solved in previous video, so you can watch all this video. Now in question 4 you are asked, you are given first of all that if WF means, here you can understand wave function, I write it in short form, wave function is given as 1 by 2 n stat plus 3 by 2 m stat. Okay, this is a cat notation, you can understand now, bracket notation. Both stat having energy E1 and E2. So here n stat have energy E1 and m stat have energy E2. Okay, respectively. Then what is probability of measuring energy E1? So what we have to do? We have to measure the probability of energy E1, that is this state, n state. So in such type of question I already explained. So again I am going to explain. First of all, write your wave function. So your psi wave function will be given wave function 1 by 2 and 3 by 2. So your wave function is given as 1 by 2 n stat plus 3 by 2 m stat. So what we have to do, first of all put a normalization condition. Okay, so multiply here this your wave function with normalization constant. Here n is our normalization constant, and so put wave function as it is, that is 1 by 2 n plus 3 by 2 m. Okay, now normalization condition says that your coefficient square in sum that must equal to 1. Please try to understand what I am saying. First of all, multiply, there is n inside, so this will be n by 2 n plus 3 by 2 normalization constant, then m. So what you have to do, first of all, here n coefficient is n by 2, so take n by 2 and square it, plus m state coefficient is 3 by 2n. This is your coefficient 3 by 2n. So take it and square it. So it will be 3 by 2 n and whole square, and normalization condition says this must equal to 1. Okay, so it must equal to 1. Now simplify this, you get n square by 2 plus 9n square by 4 is equals to 1. So now again I am simplifying further. So multiply divided by 2, this is basic mathematics, you can solve this. So 2 plus 9, it will be 11 n square upon 4 is equals to 1. Okay. Okay, here I made mistake, I think. Yes, very sorry, I didn't square here, this is not required. I forget to square. So okay, look at here. Here n means n square, and here 2, and 2 square will be 4. Okay, so here only remain 10. 9 plus 1, 10. 10 square by 4. Okay, now n square will equal to 4 by 10, so it will be 2 by 5, and your normalization condition constant comes out to be under root 2 by 5. Okay, now again substitute this value in your wave function. Our wave function was like psi is equals to n by 2, n by 2, n by 2, n plus 3 by 2 n and m stat. Okay, now n we got under root 2 by 5, again 1 by 2 as it is, n stat plus 3 by 2, n is under root 2 by 5, n stat is m. Now we are asked to find probability. So for probability of finding E1 energy, here you know n stat is related to energy E1 and m stat is related to energy E2. We are asked to find probability of finding energy E1. So it will be P of E1, and E1 is related to state n. So take coefficient of n stat and square it. So P of E will be under root 2 by 5 into 1 by 2 whole square. So root 2 square will be 2, 5 square will be 25, and 5 square will be 25, and here 1 by 2, so its square will be 1 by 4. Again here root 5 here root 5, so it will be only 5. Okay, now 2 2s are 4 and 5 2s are 10, so P of E1 will be 1 by 10. So your P of E1 is 1 by 10. So correct option will be 1 by 10, and this option in this MCQ is C. So option C will be correct. Option C will be correct. Now move to the next question. Your next question is question number 5. It is asked. It is about nuclear physics, and here you are asked for spin and charge of up quarks. Okay, so spin and charge of up quarks. So please remember there are 6 types of quarks in nuclear physics. I mentioned all it here. Here quark, 6 types of quarks are there. Up, down, charm, strange, and top bottom. Top quark and bottom quark. Remember in this fashion. Okay. Now I will write charge and spin here. Please remember all quarks are fermion, so the spin will be 1 by 2. Here I write charge. The quarks I write left side, that is up, charm and top, have charge plus 2 by 3e, and quark at right side, down, strange and bottom, have charge minus 1 by 3e. And since all quarks are fermion, the spin is always 1 by 2. And again remember there is baryon number to these quarks also, and baryon number will be 1 by 3 for each quarks, because quarks stay inside the nucleus and proton have baryon number 1, so quark have baryon number 1 by 3. So here you are asked for up quark, so from data you can see up quark has, first of all, spin is 1 by 2 and charge is plus 2 by 3 e. So correct option will be A. Okay, that is for today.